middle 68% of your employees make. I also should have told you this was bell-shaped. Let's pretend I made a better example than this. So pretend that you know it's bell-shaped. So it's symmetric, it follows that curve. And when I start talking about the middle percentage of things, I'm not wanting you to count up. It's not like doing percentiles. It's just saying, well, if you know it's bell-shaped, then you know the mean is in the center. And I know 68% lives within one standard deviation of the mean. Now we wrote it in terms of z-scores up here, but I can just as well leave them in actual salary data value terms. So I'm going to take 41.5, the mean, and I need to add and subtract one standard deviation. That's going to get me my middle 68%. So 41.5 plus 5.3 and 41.5 minus 5.3. I get 46.8 is the upper and 36.2 is the lower. So I'd say the middle 68% of employees are making between 36,200 and 46,800. Now I'm telling you next that Steve makes $36,000, so his pay scale is like here-ish. Using the empirical rule, do we think this is unusual? So I forgot to mention earlier when I was filling this out that this 95% is the realm of usual, meaning it's not considered statistically unusual until you break out of this range. The middle 95% is typical. Anything beyond that, meaning beyond 2 standard deviations from the mean, will be considered statistically unusual. So I need to know, is Steve statistically unusual? Is he more than 2 standard deviations away? So we get an idea that he's probably not, because he's right next to 36.2, which we said was only 1 standard deviation away. You can quantify that a little bit further by finding his z-score, by finding how many standard deviations he is below the mean. 41.5, sorry. So I'm going to just transform it into a standardized score. So 36 minus 41.5, and I'm going to divide that by 5.3. I'm getting about negative 1.04, which makes sense. We are seeing it's below the mean on that picture. We saw that it's around -1, meaning around 1 standard deviation below the mean, but because it's only slightly over, it's not really that far from -1. So not unusual. This is not an unusual z-score value because it's between -2 and 2 standard deviations from the mean. So really, if we're hiring another employee, they could expect to make about what Steve does, because 95% of the employees, the usual amount, will be 2 standard deviations from the mean. Now, it wouldn't be uncommon to make more because he is on the lower end. He is a little more than 1 standard deviation below the mean, but 95% of people live in this zone. It's not an unusual amount. So we can use it to interpret things like that. We can also use it for a problem like this. I'm going to use blue. I'm actually going to use a lot of colors. So I'm also not going to use z-scores for this one. I'm going to use actual data values, meaning I'm going to start by putting the mean in the center, and I'm going to repeatedly add 1 standard deviation of 100, and I'm going to subtract 1 standard deviation of 100. We usually only fill this out within 3 standard deviations because the others are extremely unusual, and it just doesn't make sense to bother with it. So I want first the percentage of people that are from 390 to 590. Well, that's 1 standard deviation from the mean. 68%, we said earlier, based off of your empirical rule, 68% of the data will lie 1 standard deviation from the mean. So that's 68%. I'm trying to think of what I want to say on that. I'm going to jump to part C next, because it's now not saying the middle, like it's not giving a start and an end for the middle. It's saying I want to be in the highest 16%. So I want the top 16%, starting at infinitely large, coming this way. I don't want to stop until I hit 16%. That's what I'm looking for. So there we go. So I need to actually divvy this up a little further. Yes, 68% lives within one standard deviation, but I know the mean's the middle. So if I take half of 68%, that tells me 34% lives in this space and 34% lives in this space. Because it's symmetric, it has to be split in half. And I can do some similar reasoning here. If I know 95% lives completely between the green, and I know 68% is already spoken for here, then I can find the leftover by subtracting 95 and 68. So 95%, 68%, that leaves me with 27% total, but I have to chop it into two halves. Half will be over here, so here's 13.5%, and half will be over here, 13.5%. So I'm writing it up here. It's technically living in this space of the curve. It's just when I go to the next value, it's really hard to label that, so I wasn't going to bother. But I do need to think about going 3 standard deviations from the mean, the 99.7, almost everybody. So if 99.7 is there, and we already said 95% is spoken for in the middle, I need to find the difference. So the difference from 99.7 and 95 is 4.7. And I'm going to chop it into 2 equal halves because it's symmetric. So 2.35% technically lives in this little bitty space. And 2.35% is in the other little bitty tail on the other side. Half of the difference of the middle 99.7 and this 95. But that's technically not 100% of the data. We just said 99.7 lives from here to here. That leaves a small but not zero amount left over. So if 100% of the people are in this distribution and 99.7 is there, if I subtract those, I'm getting 0.3%. And half of 0.3% leaves me teeny tiny little 0.15% here and 0.15% here, which is why it looks like it doesn't exist, because you can't zoom in enough to demonstrate 0.15%. The whole reason we did this is because we are looking for the top 16%. So if I start infinitely large and move my way over, if I stop at 790, that's only the top 0.15%, not enough. So I'm going to move over again. If I do 0.15 and 2.35, that's only the top 2.5%, not enough. So I'm going to move over a little further. If I stop at 590, that's the top 0.15 plus 235 plus 13.5. If I sum all of those, I get 16%, which means if this school wants to be that picky, then they need to put their cutoff score at 590. We're not going to do a ton of times where you have to chop it up that much, but because it's symmetric, you can do that. And then lastly on here, I have the student scored 795, so really, really uncommonly good. I don't want to just say student did good. I mean, it's true, but I'd like to quantify it a little more. So you can say it's extremely unusual to have that score because he's more than 3 standard deviations away. You could quantify that by fully calculating their z-score, by finding how many standard deviations they are above average. So if you did the z-score thing, you would, if you did it right, I guess I didn't, you would get 3.05. So this is more than 3 standard deviations away. That is extremely unusual. You could also talk about in terms of percentiles. Remember percentiles? That's not what I want. Percentiles are the percent that fall below you. Since we know that they're just above that third standard deviation mark there, I can basically think of, well, what percent are below them? So if I know 0.15 are above them, then the complement of that, 100% minus that, are below them. So that means that score is around, it sounds ridiculous to write it, but they're around the that's not what I wanted to say. They are around the 99.85th percentile. And anything above 95% is considered unusual. So I would say very unusually well. Whoa. Sometimes I don't like this app. So we sometimes get that in context of a problem like this, and then sometimes I'm going to give you problems where it's just making interpretations. Still pretty similar to what we were just doing though. I still know my means in the center. If you want it in terms of a z-score, okay, but that's going to be a lot of converting, so I'm not going to. I'm just going to fill in one standard deviation above the mean repeatedly and one standard deviation below the mean repeatedly. First question I'm actually going to answer is going to be C because it's easier. If I want to find the percent from 100 to 85, that's from average to one standard deviation below. We said if you go one standard deviation above and below, this is the 68% using the empirical rule. So that's the half of it we found earlier. That's 34%. And I don't know if I said it on this video or not, but those are approximations. It's for sure not exactly that. It's just close. We'll talk about a way to calculate it later in this class, but for now, that's enough. So when I go to find larger than 115, there's a couple ways you could do this. I could basically do what we did up here and revisit all these tiny little areas. It's not wrong to do it that way. There's the other way you could have reasoned this out. We could say I'm wanting to be above this. So that's everyone who is not below this. I know this is my halfway point, 50%. I know this is 34% because of what we just did in that last problem. Half of 68 puts 34 here and 34 here. So if 84% lives here, then that means 16% lives here. Different ways to get to the exact same solution we had on the other problem. Remember on the other problem we added 0.15 plus 2.35 plus 13.5. You can get the same answer this way. So next, I want the probability that an individual scored, sorry, I'm distracted, that an individual scored less than 130. So 130 is 2 standard deviations above. So the way I did this, the way I think is easiest is to go back to what we already did, this work here. Because even though this one was about SAT scores, it's irrelevant. All symmetric data will follow this rule. So as soon as you see I'm at the z-score mark of 2, essentially 2 above, it's going to be using these percentages. So if I know to the right of it is, to the right of this line is 2.35% and 15%, sorry, not 15, 2.35% and 0.15%. So that means this space is 2.5% of the data. This space is everything that's not 2.5% of the data, which is another way of saying 97.5%. So somebody with an IQ score of 130 is the 97.5th percentile, approximately. And then one thing that can get weird about this, let's use this one. If I give you a 105, 105 is not one of the nice z-score amounts. But you will notice that it's about it is a third of the way between 100 and 115. A third of 115, a third of 15 is 5. So this is about a third of the way. So you can imagine it's approximately a third. And I'm saying approximately because we're not talking about a rectangle here. We're talking about this sloped curve. So it's really an approximation. But either way, I have about a third of the way across this space. We've said a couple times now that this space is 34% of the data. So that's close to 33%, and I can do a third of 33. That means I can say it's around 11% between this blue line at the middle and this 11% line. But that's really helpful because if I'm wanting to go below 105, if I know 11% is here, that's helpful. I just need to pick up the rest of this line, and I know this line started at the median. I know it started at the mean because it's symmetric, they're the same. AKA 50% lives below that line. So I just need to add the 50 and the 11, and I could say it's approximately 61%. For sure not equal, but these are approximations, and that's good enough. Hopefully this video is good enough, especially if you missed class, especially if you were confused, you can go back and rewatch it. But Merry Christmas, hope it was helpful.